Hello and welcome. Alan Plum here again with a little more from Shed Engineering and the building of our aluminium furnace. Yes, aluminium. Sorry to the overseas viewers who might find that sounding absolutely wrong, but I'm British. The chap who had a lot to do with the refining of the metal years and years ago, way back in the early 1800s, I think was a chap called Humphrey Davy. He was British, he used the British pronunciation, so I'm sorry if it sounds wrong. To me it's aluminium. You've got more to worry about than that one word, because I've got a strong Yorkshire dialect, and many of the words I use or sayings that I use are much stranger than that, I can promise you. A quick recap, if anybody clicks on a video like this and they don't know what's going on, I'm trying to find an easy and simple solution to making a furnace. Now, most furnaces I've seen on YouTube are something like this, with a metal container, an oil drum or bucket, refractory cement inside, and a space for your crucible. You either blow propane in or use charcoal or fuel in the bottom there, and the heat obviously heats up the crucible. But you've got more surface area all around here that surely to goodness there's more heat being transferred into the refractory cement than there is the crucible. Well, that's got to be very inefficient for a start off. Can we change that? And also the heat is going straight up and straight out, whoosh, and it's gone. It's spending microseconds passing the crucible, and even then most of the heat is going into the refractory cement, and you've got to heat all this volume up to a very high temperature before you get the crucible up to temperature. So is there a better and simpler way of doing that? Sorry, I'm trying to rush on. This is all explained in the previous video, but this will just give you a quick idea. So same kind of thing, you have your crucible, your fire bed. Instead of a single blowhole blowing air in, I'm bringing it in underneath in a duct, forcing it up through a fire grate. That way you should be able to get a more even distribution of air through the fire. And instead of all that heat going into your refractory material, put a steel liner in, a steel liner there and there. You're almost doing things in reverse. You're almost putting the drum on the inside, although the thickness of a drum might not be sufficient. So the most important thing is having an air gap. You can't get much cheaper than air. It's a very good insulator, and now any heat trapped by this liner has got to jump across that air gap before you start heating all that up. The other idea is that if you could have fins on the crucible, you increase the surface area and you would capture more heat rather than it going straight up and out. That could have a problem when you take it out. The fins are then working in reverse, getting rid of the heat, a bit like a motorbike engine, but I'm sure with the extra mass of hot metal, it wouldn't be a problem. You'd be able to do your pour before it had any effect and cool down the aluminium. So that's another idea I'm working on. Whether I'll get round to that in this video, I'm not quite sure. This will give you some idea of what I'm doing. I started off with like a pastry cutter idea around the bottom, but then this is a much better idea. Fins around, creating a spiral, and obviously instead of the heat whooshing up and straight out, you're making it go round and around and around. Any heat is captured by the fins and transferred into the crucible, and that has got to be a lot more efficient. Now, I'm no expert on thermodynamics or anything like that. These are just my own thoughts. I've got a bad habit of sort of trying to improve things and, you know, go about things in a different way. So that's the general idea of my furnace build, and this is the first firing. Cheers. So here we have Shed Engineering's aluminium furnace, the lid to one side. Those blocks, by the way, can be easily cut with an old saw, and each one of those probably took only 10 minutes to carve the semicircle out. There you can see the inner furnace liner I was explaining, and more importantly the air gap, which is giving the insulation to the thermalite blocks. The crucible is obviously stood inside with the fins around the bottom. This is my first attempt at fins, which were like a pastry cutter, in the hope that they will capture heat. Now remember, this is my first attempt at anything like this, and I was very uncertain about the stability of the crucible sat on the fire bed, and that's why I've made that upstand, but in actual fact that will soon prove to be a major failure. The air channel, the other air channel rather, is blocked off with a block cut to size and pushed into that air channel and covered over with duct tape, and at this size we've got the blowpipe fitted into the channel with a simple cheap air dryer. So let's get some kindling in there and get her fired up. So we've now built up the fire bed to the top of that ring or upstand, and we can stand the crucible in with the fins around and let her heat up for a few minutes and stand back while that galvanized coating burns off. And with the blower on, I was astonished how quickly the heat built up. Obviously the air gap acting as a brilliant insulator, keeping the heat in the centre of the furnace. The bottom of the liner was glowing almost orange and the fins bright red. Right, out you could see that the crucible is glowing cherry red at the bottom. So I'm just going to drop our first aluminium in. Obviously that'll take a little while to melt and create a pool at the bottom. But with the blower on for not much more than a minute, you can see how quickly that has got tremendously hot. Many of you will appreciate how difficult it is to get shots of the furnace. There is so much heat pouring out of the furnace that I'm holding the camera on the end of the tripod some 5 or 6 foot up in the air on zoom to try and get these shots and keep it out of the way of the heat. And I say, to me it was working tremendously well. Even without the fan on, it was still retaining a lot of heat. If you want access, you can just move the bricks away, the thermalite blocks away. There was no appreciable warmth to the outside of the furnace blocks. I couldn't really feel any warmth at all, and as you saw a second ago, the blocks covering the top, I can easily put my fingers within a couple of inches of the chimney, which says a lot for the thermal qualities of the thermalite blocks. So we filled the crucible up with some more aluminium and give her another blast. Now it didn't take very long before that all melted down, and we'd got 3 quarts of a crucible full of molten aluminium. I gave it a skim and got some of the slag off and left it for another few minutes. Had another stir to take some more slag off, but it felt very gritty. Now, having no experience at all of what molten aluminium feels like, I couldn't understand what that was. I thought there must be an enormous amount of slag in the melt. Now, I know that extrusions have got a lot of oxidization on the surface, and that's why I was casting the aluminium into ingots to try and refine it a little bit. But as I say, I couldn't understand why it felt so gritty. I closed it up and carried on with the blower going to heat it up some more, had another feel, and it was almost even grittier. And I thought, goodness me, there's an enormous amount of slag here. I'm not going to have any decent aluminium at all. And it wasn't until the furnace had actually cooled down that I realised what a absolute stupid blunder I had made in putting that ring or upstand in. So by now I'd actually stopped filming and didn't pour the crucible of aluminium. Right, let's just take a look at the furnace now that it's cool. As you can see, I've cleaned the ash out at the bottom, and with the design of the air channel coming in at the bottom there, then it's very easy to scrape the ash out and clean it out. The stainless steel perforated metal that I used as a fire grate seems perfectly alright. Nothing wrong with that. A little bit of crazing in places on the furnace itself, But as you can see, there is nothing wrong with that. The furnace liner is pretty much intact. Obviously some surface scaling, but that's more or less just the protective coat on the steel burning off, I think. I did pull it in with the wire and reduce the diameter, and it is now taken on that shape because it was so hot. And again, inside, a little bit of surface scaling. I think with the thickness of the plate there, I think that'll stand up, and it only cost me £5 anyway, so you consider that as like a sacrificial liner. The crucible is fine, nothing wrong with that. The fins that I had round the bottom, the galvanised coating has burnt off, and that is still fine. The other section of fire extinguisher is obviously fine, that'll stand up to many firings. My obvious mistake was not to cut big holes out around the bottom, so that as I dropped more fuel in, it could get underneath. What actually happened is that all the fuel burnt away in the centre. That's why it got hot so very quickly, and the heat was coming up through these holes, and as the heat came up, it was being captured by the fins, which were the general idea, transferring more heat into the crucible. But obviously when the fuel ran out in the centre here, you'd just got cold air being blown up through the fire grate, and that's why I lost temperature. But I've got a different design for some fins, which I will show in a while. The blowpipe is fine, that didn't distort. I warmed that up with the heat gun to mould it to the shape of the opening, but that hasn't distorted in any way, shape or form. Just looking round the base of the furnace, nothing of any consequence. A little bit of surface crazing, but they're perfectly intact. There is the other one. Again, perfectly all right. And they only cost about 85 pence, less than a English pound, so I'm quite happy with them. They will last several firings at the very least. So all in all, quite successful. Just need to alter that upstand, or simply stand the crucible straight onto the fire bed, which is probably what I'm going to do. So there we go. What looked like a very promising start because it was heating up so quickly soon turned into a complete and utter fail. In hindsight, it's pretty obvious the fuel will run out eventually in that centre ring, leaving just cold air coming up through the fire grate and cooling the crucible down. But I'm sure the fins around the crucible made a big difference. I think that looks promising. But just you wait until you see the spiral turbo fins working. They actually wrap the hot gas and heat around the crucible several times, and I think the fins are really extracting as much heat as possible, and obviously it stabilizes the crucible and stops it falling over so it can go straight down onto the fire bed, and I'll show that in my next video. If you do subscribe and you want notifications when new videos are posted, remember you have to click the little cogwheel next to the subscribe banner. I hope you found something of interest, and as always, many thanks for watching.